All right, guys. Hello, this is Coach Lorton, and I'm going to be talking to you about some more transformations. And we're not talking about the Incredible Hulk transformation. We're actually talking about math transformation. So, in this lesson specifically, we're going to be talking about reflections. So, let's move on and let's talk about reflections. Okay? So, first off, I want to define to you what a reflection is. So, when we reflect something, we're actually going to be flipping it. We're going to flip it over the x-axis or we're going to flip it over the y-axis, okay? But a reflection, it's a transformation on the coordinate plane that flips a figure over an axis. We're not talking about an axis, we're talking about the x and y axis, all right? So here we are on a coordinate plane. We have our x-axis and then we also have our y-axis, okay? So we can flip it over the x-axis or the y. So the points of the reflected figure are the same distance from the line of reflection, okay? So this is some pretty big words. There are a couple words that you've been hearing from us pretty regularly through this unit, and that's orientation. So when we have a reflection, the orientation does in fact change, okay? The orientation changes. But when we reflect something, the sides and the angles, they all remain congruent. That word congruent is that math term that means they are equal. So the angles and the sides remain the same. They remain equal, okay? So let's move on to this next slide, and we'll show you what a reflection really looks like, okay? So this is an example of a reflection over the y-axis, okay? It's over the y-axis. We're starting on this side. Here's our y-axis, all right? Going up and down. We start on the left side, and then we move to the right side of the axis, okay? And so down here at the bottom, we have the algebraic rule. The algebraic rule is xy becomes opposite x, y, all right? Opposite x, y. So in this first one, here on the left, looking at this a on the left, this first a is at, let's see here, 1, 2, 3, 4, 5. It is at negative 5. Those are all negatives. Okay? And the y is at 1, 2, 3, 4, 5, 6. So it is at 5, 6. If I can write, Coach Lorton. Okay? So when we reflect this, when we do a reflection over the y-axis, the easy thing to remember is that the y will stay the same. We see a prime over here. The y is going to stay the same. But the x is going to become opposite, okay? So here it is negative 5. Over here, it's going to become positive 5, okay? So that's kind of that's the rule in effect, is the xy, the x becomes opposite, the y stays the same, and reflect it over the y-intercept, okay? But key note is that the orientation changes, okay? Let me erase everything that's on here right now. You'll notice this one on the left, the A is on the top left, but when we reflect it, the A is now on the top right. So the orientation changes, okay? The orientation changed from triangle to triangle, all right? So now we're going to go over a reflection over the x-axis, okay? Over the x-axis. Let me try to minimize this. No, it's not. Let me hide it. Anyways, all right, there we go. Hopefully you can see it now. But when we reflect an object over the x-axis, the x will stay the same, but the y will become opposite, all right? So we're reflecting over the x-axis this time. So we're going from A to A prime. So on this, we see that the x's stay the same, but the y's on this become opposite. Over here, on the top one, the y is positive 4. The opposite of positive 4 becomes negative 4. So when we're reflecting an object over the x-axis, the x stays the same, the y becomes opposite. Okay? So now we're going to do a couple of examples here. We're going to reflect this triangle over the y-axis. Okay? So we're going to be reflecting it over the y-axis. All right, so when we reflect over the y-axis, we know that we'll have an x and a y. when reflected over the y-axis, my y is going to stay the same, but my x is going to become opposite. All right? So this first point here is at 1, 2. All right? This point here, the bottom right point, is at 1, 2, 3, 4, 1, 2, 3, 4, 4, 1. And this top point up here is at 2, 1, 2, 3, 4. Okay, so we're going to reflect this triangle, and you should have a copy of your notes to be able to reflect this with on your notes here, so you can just copy down everything that we're writing. I'm going to do this next part in red. So let's do this top point here. All right, we're going to do 2, 4. So I know we're going to reflect it over the y-axis. So my y, my 4, is going to stay the same, but my x is going to become opposite. So my new point is going to be at -2, 4. That's going to be my new point. So I'm going to go graph it. -1, 2, 4. 1, 2, 3, 4. So the y stayed the same, but my x became opposite. Let's look at this bottom left one. So we're going to be right here. I'm coloring in red right now. It is at 1, 2. So my y is going to stay the same. It's going to remain 2, but my x is going to become opposite. So that's going to be -1. So my new point over here on the left side is going to be at -1, 2. All right. Now we have our bottom right vertice. It is at 4, 1. So we're looking at this one here. I'm coloring it red. It's at 4, 1. So my y is going to stay the same, but my x is going to become opposite. So it's going to become -4. So now we're going to be at -4, 1. -1, 2, 3, 4, 1. All right. I'm going to connect this. And voila, we have our new triangle over here. Okay? So again, we did it over the y-axis. So when we reflect it over our y-axis, the y stays the same, the x becomes opposite. Okay, so now let's do this next example. For this one, we're going to reflect the triangle over the x-axis. So let's go over this rule. So we'll have our x and y coordinate. Okay, so we're going to reflect it over the x-axis. That means our x is going to stay the same, and now our y is going to become opposite. Okay, so we're reflecting over the x-axis. All right, let's go back to blue. We'll start in blue, and we'll move to red. So let's look at this bottom left point. This bottom left point is at 1, 2. All right, this top point is at 2, 1, 2, 3, 4. All right. And then our bottom right is at 1, 2, 3, 4, 1. Remember, this is our x-axis. This is our y-axis. All right, so let's reflect this over the y-axis. Let's look at this bottom left one first. All right, so we're going to reflect it over the x-axis. So my x is going to remain the same. So it's going to be at 1, but my y is going to become opposite. So the new point is going to be at 1, -2. Okay, now let's go to this top one up here at 2, 4. So my x is going to stay the same. So I'm reflecting it over the x-axis, but my y is going to become opposite. So now we're going to be at 2, -4. 2, -4. 1, 2, 3, 4. All right, now we're going to the bottom right one. My x stays the same, so 4 is going to stay the same, but my y is going to become opposite. 4, -1. So 1, 2, 3, 4, -1. Boom. We reflected it over the y-axis. So, man, I keep on almost stepping off my stage. You should see me. I'm dancing around up here. But just notice the shape stays the same size. The sides remain congruent. The angles remain congruent. Nothing about it changes in terms of shape. Okay, but what does change is the orientation. The orientation changes, all right? So the vertices are not facing the same direction. So when that happens, you know you got a reflection. All right, guys, I hope this made sense. If you have any questions, make sure you attend a workshop or raise your hand. All right, bye-bye.